We've all been there. It's midnight, you're staring at your phone, obsessively refreshing the train booking app, and praying that WL42 turns into a confirmed seat. It feels like you've been dropped into a single, chaotic, nationwide queue, standing shoulder to shoulder with millions of other travelers, hoping the line moves. But looking at this diagram, we see how the system actually works. IRCTC is merely the dashboard you interact with. The real brain making the allocations is a separate organization called CRIS, and its Passenger Reservation System, or PRS. When this reservation engine first booted up in 2002, it handled exactly 27 tickets on its opening day. Today, that processing core churns through over 18 lakh e-tickets every single day. During the peak morning rush, it absorbs up to 3 lakh concurrent user requests, all hitting the servers in the exact same second. Getting a confirmed berth means navigating this massive back-end architecture. You aren't hoping for good luck. You are waiting for the algorithm to sort you through its decision tree. The first major branch in that decision tree is the Quota Assignment. Train inventory isn't first come, first served. It's pre-sliced into distinct quotas: general, tot call, ladies, and defense. You're locked into your slice, competing only against passengers in your category. A canceled tot call seat stays in tot call. It won't help the general queue next door. The speed at which your waitlist number drops is entirely dictated by the size of the pool you are sitting in and how often the people ahead of you change their travel plans. The highest probability category is GNWL, the general waiting list. Because it applies to journeys starting from the train's origin station, it has the largest pool of seats and sees the highest volume of daily cancellations. If you board at an intermediate station midway through the route, you might receive RLWL or PQWL, remote or pooled quotas. These are much smaller seat allocations reserved for local populations. Looking at this route map, the math of the remote location waiting list becomes clear. Your movement relies almost entirely on cancellations within that tiny midpoint allocation. If 50 people cancel at the origin station, your local waitlist won't budge. Sitting at the bottom of the probability ladder is TQWL, the TAT call waiting list. It rarely converts into a confirmed seat because it completely lacks the built-in RAC safety net phase that the general waiting lists have. That safety net is RAC, which stands for Reservation Against Cancellation. RAC guarantees you can board the train, but you will share a side lower berth with another traveler, sitting rather than sleeping. As fully confirmed passengers cancel, everyone in the RAC queue slides up one spot to claim the empty beds. The acronym assigned to your ticket is a mathematical indicator of your final status, mapping exactly which track your booking is on. The ultimate deadline in this process is chart preparation, which takes place exactly 4 hours before the train departs. At that precise moment, the algorithm halts. The lists are frozen, RAC passengers are locked in, and any e-tickets still left on the wait list are automatically canceled and refunded. Without that confirmed or RAC status, waitlisted e-ticket holders are legally barred from entering the reserved coaches. This rule exists strictly to prevent dangerous overcrowding inside the train. Frequent travelers use a specific technique to navigate these rules. They book a ticket starting from the train's origin station, even if they plan to board halfway down the line, specifically to secure a spot in the fast-moving general waiting list. Once they have that ticket, they log back into the system up to 24 hours before departure and legally change their boarding point to match their actual location. Everything about your journey is encoded into the data, right down to the 10-digit PNR number. The first 3 digits identify exactly which regional center processed your request. Getting a seat on an Indian Railways train is not a gamble against a random queue. You are successfully navigating one of the most robust quota management engines ever built.